Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Are generally centered on natural language generation, but the work presents in many forms includes summarization and multimedia exploration, working with basic libraries, and new concept of speech generation. Today, this one talks to us about online summarization. And just want to say that you must have created a really interesting and exciting work environment at Columbia University where she established a natural language processing group. We have the good fortune to have one of the Flint students with us, Annie Mankova, who's working with me on summarization. And last week we heard from one of her former students, Darwin Murata, about his work at the University of Michigan. So it must be a good place to work. And thank you for coming.
Okay, thanks, Lucy. So, can people hear me? This is, okay. All right, so we've been working on text summarization for quite a while now. I'd say at least 10 years that we've been looking at it. And I'm going to talk today about our work on news, but also directions of where we're going as we move to different kinds of news and other kinds of media. So we do a lot of work on summarization at Columbia, and I won't be talking about all of it here today. News is clearly one. We're beginning work on summarization of email, and we have some initial results in that area. We're also even more beginning work on summarization of meetings, and have even more initial results in that area. We've done work on summarization of journal articles. That's part of our digital library project, and I won't be talking about that today. And we're also looking at using summarization to answer open-ended forms of questions in question answering systems. So definitional questions, like what is a loya jirga, biographical questions, who is a particular person, and I guess you can see our work, who our work is funded by, or opinion related questions, you know, what do people think of, for example, welfare reform? And here we use summarization techniques, but we target them to bring back and organize people that is, or organize information that is relevant to a particular question. So today I'm going to talk about our work on news. I'll start off by giving you the current status, what we can do now, and the different kinds of things that we've pursued. And I'll talk about our directions also in news, so things we're working on that we're not there yet with results, and there are some very interesting and challenging problems there. I'll also talk about our work on email summarization and give you an idea of where we are with that. This is very much ongoing work. And I'll say just a teeny bit about our work on meeting summarization. Okay, so our research focus is in monitoring a variety of online information sources, and where news, and now we're moving towards multilingual news, and email are some of those sources. Our work looks at gathering information on events across both source and time. So given a stream of information from a particular source, we'd like to be able to identify what events are occurring, what documents do we have from different sources on those events. And up till this point in time, we've worked primarily looking at events that occur in multiple sources, but on the same day. We're now, and I'll show you work that we've done where we've moved towards being able to identify events across time and give updates on what's happening today versus yesterday. For each of the events that we identify, we generate a summary. And we've done a lot on generating summaries which highlight similarities across the different sources. We're now moving to generate summaries that can highlight what's new. to be able to give different perspectives from different sources on the same event, or to be able to give user-specified interest in real time. And this last, the user-specified interest in real time, is something which we're now collaborating with Luis Gravano at Columbia, and his group is looking at how to incorporate search and filtering as part of our environment, and I won't be talking about that today. So our approach to the problem is to use a hybrid of statistical and linguistic knowledge. We use statistics to allow us to scale and handle a wide variety of topics in an unrestricted way. And we use linguistic knowledge or symbolic approaches to get at a little more detail and be able to look at things in slightly different ways. So we're using statistical analysis of multiple documents in order to be able to identify important information, new information, and contradictory information. We use symbolic approaches like information fusion and some rule-driven content selection rules in order to identify similarities and select information. Our work also features the use of generation. So many systems that do summarization work by what's called extraction, where they extract key sentences from input articles, and the extracted sentences are strung together to form the summary. We do some of that also, but we're also looking at being able to reuse phrases from the input article and put them together in different ways in the output, and also to do some automatic editing and rewriting of the summary for cases where we do extraction. So I'm going to start by talking to you about our work on Newsblaster, which is a system that we've been developing for, well, let's see, I guess we put it online right after September 11th. That seemed to me a good time when we had enough capability that we could do it, and we were also interested from a research perspective in finding streaming documents over a period of time on the same event where events may fork, and this was a good time. We thought we could collect a lot of news on the same topic. This is the group, and it continues to grow. We need to take a new picture. And so in addition to the people shown here, there are still, well, Luis and one of his students and others are joining. So this is the URL, and in Newsblaster, we have several different components. We do work on downloading. We crawl the web each night, download articles, cluster those articles into events, so recognize what events have occurred, categorize the events by broad topic. So the clustering looks at what emerges overnight in the news. The categorization starts with an a priori set of topics and fits the events into those. And then we do multi-document summarization. So given a set of articles on the same event, generate a summary. And within Newsblaster, we use two different techniques to help augment extraction. That is the use of fusion and editing of references. So this is the architecture for Newsblaster. It runs once a night. It takes about, every night it takes about 6 to 8 hours to run. We crawl news sites, download articles. We download, probably about 3,000 articles a day. Right now we're crawling some 25 to 30 different sites. We then do clustering to form the clusters. Those are all categorized, and from this set of data, then we generate titles for the clusters. We select images that illustrate the different events that we found, and then we select a summarizer for each one of the cluster of documents on an event. And we have several different forms. We have two that focus on different kinds of events. One when we've got a really tightly focused set of articles, and another when they're more loosely focused. And we also have one version which will do focus on a set of articles that are about a person. Okay, so now I'm going to intersperse the talking with some demos to show you how this works. Okay, so this is the front page of News Blaster. This is Sunday's news. At the top, you see one of the events. This is clustered, and over the last several days, the news has focused quite a bit on the presidential campaigns. So at the top, we have several events related to the campaign here on Kerry, Bush, Kerry, and so forth. If we look down, we have several others, and top news is just done by the number of articles that appear, so how much news appears within a cluster. We have multi-level clustering, so you can see we have a story here about Al-Sadar, and then we have related stories on the same topic. So these would be other events which are closely related to that. Further down, you can see the categorization. So here we have 6 categories: U.S., World, Finance, Science, Technology, Entertainment, and Sports, and more events that have been clustered within those. On the left-hand side, you can see the different sources that we go to, and we do have some work on machine learning to automatically help us in automatically adding news sites that we want to be able to crawl. Okay, now if we look into one of these, we'll see the full summary, and behind the summary are references into the articles from where the summary sentences were drawn. And this first one gives some idea of our work on editing the summary sentences for references. You'll notice here Bush and Kerry campaigned Wednesday, and if we look into the article from which it was drawn, you can see that here we have regenerated the references since it's the last sentence in the summary, and we know we've already heard about who Bush and Kerry are. Modifiers are dropped, and we're just using the final name. On the other hand, towards the beginning of the summary, here where Kerry is first introduced, we have Democrat John Kerry, a fuller reference. And if you go into the article, you'll see that here again it's been modified from what occurs in the article. Yeah?
For your categorization, is that based on clusters or based on individual articles?
The categorization?
Yes.
Categorization we have set up ahead of time 6 categories. We use fairly standard text categorization techniques. And for each one of the clusters, we will determine which category it best matches.
So you do that for class by class, not for article by article?
Yes. Okay, so that gives you an idea of the general framework of the system. And now I'll tell you a bit more about some of the details. We can go back to the archive, and I guess, well, we may see that at certain points in time. Okay, now, as I mentioned, one of the techniques, language generation techniques that we use to be able to generate the sentences is information fusion. And this will not occur in all of the articles, and it is a more time-consuming process, and so less of the clusters are generated using fusion just because of time to run things. This shows the general architecture that we use for fusion. So first we compute, when we're doing summarization, the first thing that will happen is we'll compute a theme. So we want to find out, given a set of articles as input, what are the common themes that occur in those articles? So can we find across the articles sets of sentences which roughly refer to the same thing? And this is the theme computation, and you can think of it as that for each one of these themes, which consists of a set of sentences, we'll have roughly one sentence appearing in the summary. After all the themes are computed, then we need to select which one of those will occur in the summary, and we do that partly based on how many sentences, how long we want our summary to be, but also some notion of importance of each one of the themes and how well it connects to the other themes. We then order the themes.
Can you define a theme?
Yeah, so a theme is, we have an example of theme at the bottom. So here is a set of sentences that were found in an input set of articles that all roughly talk about the same thing. So for a theme, we're going to be looking for, across all of the articles, we use a clustering technique and similarity metrics between sentences to pull out those sentences that are most similar.
So is it you're doing sentence by sentence similarity?
Yeah, sentence by sentence similarity, yeah.
Don't mean, for example, the private school theme and mean.
No, no. Okay. Yeah, so here we have a set of sentences which all talk about this one, particular action, that is when Palestinians fired a missile at a bulldozer. Okay, and so you can see from the different sentences there's repeated information shown in the bold where we have the same information repeated but in somewhat different ways. And then each one of the sentences also includes some additional information. And the idea for the fusion, we're going to take a number of these themes, and this will constitute what's similar across all the articles and therefore determined to be important and should incur in the summary, order them, and then do sentence fusion with this set of sentences to produce one sentence which represents the information that occurs across all of them. So how do we do that sentence fusion? And actually, I should say, when we're doing this, it's a form of generation. It was quite a challenge when we started it because we're generating from text. So we have input text, a set of sentences, and we have output text. So it's a form of text rewriting. In contrast to most generation systems, we're lacking information that you would normally have. Most generation systems work from a semantic representation of input, and we're lacking semantics about the input. And so, on the other hand, we do have some information about what the output might look like that we don't normally have in a generation system. So when we started, it was a real challenge to us for how to do this. And we do it takes 3 stages. First, we identify common information across the set of sentences, so what we saw before to identify the bold. From that common information, which are phrases now, not full sentences, we construct what we call a fusion lattice, which represents the combination of different information. And then given this lattice, we linearize it to form the actual sentence. Now, some of the specifics about how we do each of these tasks. To identify common information, we will align constituents across the theme sentences. So it's an alignment task, but it's actually quite different from alignment that's usually used, for example, in machine translation, where you're looking across languages. We want to align constituents in parse trees, and furthermore, not everything in these parse trees are going to match. So we have information that appears in one that won't appear in the other. And the subtrees may occur at very different positions. They're not going to be, you're not going to align left to right as you move across the sentences. Only some of the subtrees in the end will match and will be included. So given this kind of problem, we chose a method used bottom-up local multi-sequence alignment, which has the property that it allows us to identify local pieces that match and pull them out. We do similarity across these subtrees based on word similarity between nodes of the trees, but we also make use of paraphrases, and also similarity of the tree structure in these subtrees. This allows us to build a lattice, and to do that, having identified the subtrees that match, we do it first by choosing one of the sentences which contains most of the intersections. This will allow us to generate a grammatical sentence in output as opposed to putting everything together. So we choose a basis sentence. Then we modify that basis sentence in several ways. We add information that occurred in the intersection of all of these, the majority of these sentences, but not in the basis sentence. We add alternative verbalizations, so subtrees that were determined similar may have alternate expressions, and we remove subtrees from the basis sentence that were not present in the majority of the fusion. So we have this modification. When we're through, we have a lattice, and then we want to linearize it. And to do this, we use a form of statistical language generation. We first generate all possible sentences from this lattice, and then we score which ones are the best using a statistical language model. This is work that was done by Regina Barzilay as part of her dissertation. To give you an example, here is one of the fusion lattice that was constructed for that theme which you saw before, and this is after it's gone through several stages. But it just gives you an idea how at each of the nodes you'll either have identical phrasing or alternative phrasing, and there are some alternatives in how in the structure of the tree, which gives some options as you're doing generation. Okay, now going back to News Blaster. Oops. We can see an example of where we've used this. So this comes out in a summary like this, where you can see that now, instead of having the links to the articles at the end of each sentence, they occur in the middle. And for some of them, you can see what's happening in the different articles that, some of the reasons. So for example, here in the second sentence, we have a milder adult form of the disease coming from one article, and this article lacks the information about the siblings dying. So if we look in, we can see where this was taken from. So we had one phrase which occurred here, but the rest of the sentence was not chosen. It was not similar to the majority of the sentences in that theme. And similarly, if we look back into this article, we can see that here we've just taken the first part, but later we'll take the second part. And so it has contributed the rest, and it has less of the modification than that one does. Okay. Other features of our work on summarization across news. We've been looking, as I mentioned, of moving across time, not just within days. So mostly if you look at News Blaster, what you'll see is a page that's regenerated from scratch each day with no memory of what happened the day before. And yet what you'd like to do, or for people who read the news, you want to be able to follow a story across time and watch it unfold. And so we've developed work which will allow us to, having identified an event, to track it as the days go on. To do this, we experimented with different models for the clustering. A natural approach that you would think of first would be to use incremental clustering, and as you go from one day to the next, simply add in new articles. But what that would give you is a very large set of clusters very quick, without the kind of thing that you'd really like, which is to be able to see a story starts, and if it's a big story, then there are many sub-events that occur after it, and you'd like to see that sort of forking into these related sub-stories. Yeah?
As stories unfold, they have inconsistent facts sometimes. Mm-hmm. Do you try to do anything in Fusion about dealing with inconsistency between the stories?
Yes, so that's the last point on this slide, summaries that update a user on what's new. I mean, part of the work was on developing the model for clustering, and we've developed a network model where we first cluster events within each day, and then we connect the new events to events that occurred on previous days, and so forth, which allows for this forking and merging of stories. We also had to think about an interface for doing it, which I still think there's a fair amount of interface work that could be involved here, because News Blaster, it's a one-day sort of thing, and now we're talking about another dimension, through time, and we talked quite a bit with the graphical user interface group about what would be different ways to visualize this, and I still think there's more that you could do. But then the other topic is, once you've done this and you track an event across days, when you get to day N, as a user, you really like to hear what's different, what I haven't heard before, which I heard the day before. And this is a topic that Barry Schiffman is working on for his PhD. It's actually quite a bit harder than generating similarities, because essentially what he wants to do is, given a set of articles on day 1 and another set on day 2, identify the differences between them. Well, there are many more differences than similarities, and how do you determine which ones are the ones that count and should be included? So he's done some work using machine learning and has experimented with different features. Many of these features are more semantic in nature than what we use in other portions of Newsblaster. And critically, he's looked at merging 2 approaches, one which looks for differences at sentence and paragraph level, a more traditional IR approach, and another which uses more knowledge about language and looks for differences at the clause level. Okay, so let me give you an idea of what that looks like. Okay, so if we go back, I'm into Sunday's news, and a number of these no, I don't want to do this. Okay, I think Monday's news has this. Yes. Okay. So here's a story, a cluster that was identified for today. There are actually a number of these, but this one I thought gives a nice idea of how it works. This is a story that relates to the different events that have happened in the news recently about having captured this particular suspect who gave information about the intelligence, and it led to various changes. Well, the New York area was definitely affected by this. So you can see the tracking that occurs across days and different things that have happened on different days. We see earlier, some of the reports that rose. We can recenter the tracking on earlier days, so we can see a different kind of clustering that would occur. And we can also look, okay, here you can see if we go back, the day earlier, yet the day before that, which didn't show when we were centering later, you can see where the news came out about the warning of the threats against the building in New York, and so forth. And then we can look at the update summary. Right now, it just uses extraction. Barry has been focusing more on how to identify the information that's new, and once we identify even a piece, the whole sentence would be extracted and included in the summary. So there's more work to be done there, but it gives you an idea. Okay, other work that is very much ongoing is being able to look at different perspectives on news. So we collect news from different sources and from different countries. It would be nice to be able to see, for the same event, how do different countries view that event differently. And we have begun work so far. We have quite a bit more to do in this area, but currently what we do, we have hierarchical clustering. So given a particular event, we divide our news according to what country it came from, and then we can look at different perspectives displayed side by side to get an idea of the differences. We're moving to being able to highlight those differences more explicitly. And so some highlighting would happen with content, and we'd like to make use of the update summarizer for that purpose. It simply looks at 2 sets of articles and identifies the differences in one set as compared to the reference set. And so we'd like to be able to use it that way. We're also using it in our multilingual version of Newsblaster. So let's see. if we look here, you can see the different summaries down below, and here we could compare, since it's English, we have stories from a British point of view, and then stories from a U.S. point of view. And so initially we simply place those summaries side by side and allow people to look at it so they can see for themselves what differences are. Okay, now, this is sort of where we stand and where we're moving. So where are we moving? We're moving to multilingual news, and this is also hard. The idea is, and to be able to do the crawling on the web of multilingual sources, well, actually, let me go. So the idea is to be able to crawl on the web, not just English sources, but sources in a variety of different languages, but then be able to generate your browsing in English. So you have an English view of news that has occurred all over the world in different languages, and you can do your browsing in English and then decide, once you're going into the original source languages, which source languages you want to view in more detail. So if you look at the left side, you'll see that now we have sources that come in other languages. Here, Le Monde in French, some Spanish, some Japanese. Right now, we do the crawling over, I think it's 7 or 8 different languages. And if we look in to one of these, and it will vary, you know, which articles have news from different countries, but here's one where you see the summary is done from multiple countries, from articles in multiple languages, and then underneath it we have summaries in specific languages. So for example, we can do our comparison here and look at a comparison between a summary in multiple languages and the summary in Arabic. Now, in this version that you're seeing right now, we don't do translation. So we actually at Columbia are a big user of tools. We take whatever tools we can get, and then we do the work on the summarization. Here we're using IBM's Arabic MT system. They have it up on the web, and we link to it every day. You can see that translation in Arabic is still not very good. So if you took the time to look at, I think that's one long sentence. So it gives you gives you an idea. When we were to do this work as part of our funding from DARPA, and initially, you know, we were to connect as part of a test bed and use this translated output from other companies or other sites. And when we first got it, we said, oh no, how are we ever going to do anything reasonable, you know, with this? As it turned out, when we first started, we had a version of their translator which had a bug, and so it wasn't as bad as we initially thought, but there's quite a few challenges. It, of course, depends on what language you're using. So
I'm curious, what MT systems are you using?
Yeah, so here we use IBM's. IBM's, yes, statistical machine translation, right? So it's developed with those tools. For the rest, just because it's available, you know, on the web, we use basically Systran. So we use things that are available on the web. So here you can see, I mean, here I'm choosing the one that is the best translation. German is actually pretty good. So if you look at that.
As a black box, or are you having access to some of these?
Right now we use it as a black box. We'd like to be able to, I mean, any information you can get helps us. So having access to intermediate representations or even pieces would help. But we're not at that point yet. So what you see here is what we currently, you know, we always do a version where we have something up and running which shows where we currently are. This shows not where we are in the research, but sort of what we have gotten in there at this point in time. The research, which is ongoing and hasn't moved into Newsblaster yet, the situation is this. the summarizer is given a set of documents on the same event. Some of the documents are in English. Some of the documents are translated from other languages. The problem is, as you saw, that the translated text is very noisy. There are a lot of errors, and depending on the language, and as we move to new languages, the errors are greater. But when we do summarization, we have information available during summarization which was not available during the translation stage. So we have a cluster of related articles, some of which have better translations, some of which are in English, and some of which are worse. So how can we use that information to improve the summary? So when you're doing the browsing, you can tell, where you want to look at in more detail. And we're using that information in two ways. One is to replace translated sentences with similar English sentences. This can be risky. You want to get a sentence that is close enough to the translated one that it makes sense when it goes into the summary. We're also looking at editing the translated text, and we started with editing of named entities. So named entities in translation tend to do worse than some of the other constituents, and yet it's one where we can get a good handle by looking at other English text to get a good version of what the named entity should have been. So again, it's this idea of there's a lot of redundancy on the web, and when we do this summarization, we want to take advantage of it. So here is a set of input sentences. They've all been determined to be similar. They're translated from different languages, and they have phrases, again, like in the information fusion case, which essentially say the same thing. So if we can identify the phrases in the English which correspond to those in the translated ones, we will do better if we take those English phrases. So here, you can see one in the red, which has to do with the 22 human prisoners who were killed. Here is more in the blue, which tells a bit about where this happened and how many mortars were fired. So the idea is if you could cover that entire English sentence with different colors that correspond to the translated, then you could take the English sentence as opposed to the translated ones. And that's what one of the things we're working on doing. This is the system that we've developed, where at the top we have our machine translation boxes, and the translated text which came from the different languages. From those, we'll select sentences which could go in the summary. At the same time, we'll take our English text on the same topic, also detect summary sentences, and then we are going to look in this box at how we detect similar English to the translated summary sentences and either replace the translation or rewrite the translation with what we found in the English and produce the English summary.
The information that's only in a foreign language translation is going to go into the final summary?
We're doing a mixture here of things. So if you have to do the replacement, you have to find an English sentence which is similar enough to a translated foreign sentence.
But this English sentence, similar English sentence, comes from the cluster of English text.
They're all clustered together. So you have English and translated articles clustered together. They're all on the same event.
So the translation that is good translation, but it was a new information, was not in the English cluster. How does that get into the final English?
Well, they won't all be replaced. So you're only going to replace things when they're similar enough to do it. And part of our work is, what's that threshold? When do you have something that's good enough to do it? And you may not want to replace a whole sentence. I mean, ideally, you may want to just, as we go forward, you probably just want to be replacing pieces of it, so that you can improve on the translation. Yeah.
So, from the point of view of the summary, if you've replaced part of the sentence with an English, then you might as well have just chosen the English sentence. So I guess this only comes in, helps with the summary if you replace a portion of translated sentence with a portion of an English sentence, and then you choose at least that portion and some other part of that sentence, right? So, I mean, do you actually ever get any advantage out of doing this?
Well, let me step ahead because I think I'll answer some of your questions. So let me step ahead, and then you can ask the question again if I haven't answered it. And I should say I'm showing early work, so we're at experimental stages. We're still evaluating, what's the best way to go, and Okay, so to do this, we first make use of a tool that we have in-house called SimFinder, which we use in all of the summarization processes, which compute similarity between sentences based on different linguistic features. So using that, this is another example, but given a translated sentence at the top, this was translated from Arabic, we have similarity scores that are produced for other English sentences in the same cluster. And you can see the purple is similar as far as we can tell, reading the translation. Sometimes we have a sentence which is entirely similar. Sometimes with a lower threshold, we have a sentence where part of it is similar and part of it is not. And then with even lower thresholds in the yellow, we'll have sentences which aren't similar at all. So to augment what we're doing, rather than just choosing a similar sentence, we're making use of sentence simplification. The machine translated sentences, as you saw from the first Arabic summary, are quite long. So right now what we're doing, although this is changing as I speak, we're using sentence simplification on the English side, so we reduce the sentence to clauses where we have approximately one fact per simplified sentence. And now we'll want to match these simplified sentences against the Arabic so we can choose just the part that matches the sentence. So now to answer your question, sometimes we'll select the full sentence, sometimes we'll select a piece of a sentence which matches, and as you'll see as we go further, we'll do more. Then is the summary will present multiple of these short simplified sentences as the summary. So here's some example of the simplification that we do. A longer sentence, Operation Red Dawn, which led to the capture of Saddam Hussein, followed crucial information from a member of a family close to the former Iraqi leader, gets separated into two sentences. First, following the crucial information, and second, leading to the capture of Saddam Hussein, so that you could match, one or the other. And our experiments on that, where we looked at different levels of the similarity threshold, and the simplification versus no simplification, shows the top line, the light blue, is where we do use simplification, and we use a relatively high threshold of 0.65. The second line is we use a relatively, so that's the brown, you use a relatively high threshold, but no simplification. So the high thresholds help quite a bit, and then the simplification definitely gives us an increase in accuracy. But as I said, it's very much work in progress, and we're doing, we're constantly looking at how we can improve the accuracy on that. We're also looking at this editing, so not just, short simplified sentences to replace, but can we look even smaller at the English side and take smaller phrases and fuse them into the translated side. And the named entities were the place where it made sense to start, because we can pretty reliably identify named entities. It's a place where if you have an error, it can make a big difference in your summarization. So this is even earlier work. What we've started on is using the related English text in the cluster to find similar references. And so we want to align the translated text with the English text. Note that these are comparable pieces of text. They're not identical, so the alignment is never, again, going to be complete. You're going to align portions of it. And now we want to be able to determine when we have a good enough match between a reference in the translated and a reference in the English that we can do the replacement. And so we've begun experimenting with this automated evaluation of references. That is, what metrics can you use to compute when two are close enough? And we can use it both for evaluation in the end and for the generation. And we use metrics, precision, recall and F measure. We use a metric which looks at how well we match on word order and determiner choice, since that's something that's problematic in the translations that we want to look at. So, for example, here is American Contact Unity is a translated reference in the English, and initially we work with translations, human translations of translated text to do the work to develop this. So we know that that's the correct translation. And we'll look at precision, how many words in the translation were correct out of all of those in the model. How many of those in the model did the translation get? Here there are 4 in the model, non-determiner, and the translated got 2 of those 4. For word order, we want to see how many words could be correctly ordered. In this case, 2 were correctly ordered out of 3 possible ordering. And then here, this particular one would score 0 on determiner choice. And as I said, this is very much ongoing, where we're looking at how we can do this alignment between the different translations or the English, how we can learn language models for the word order based on the related English text at runtime, so we can do a better job of generating these references, and how can we actually perform the error correction based on this kind of redundancy in the clusters and the use of the acquired language models to correct the summary. Okay, now, the last thing I will talk about on Newsblaster is we've done a user study. We are continuing to do more. And so we have various models which help us to measure how good our summaries are, but could we say that a system like Newsblaster really helps users comprehend large volumes of news? And we wanted to look at the various features that were in Newsblaster to see if those features help. So are the summaries informative? Can the summaries be used as some kind of substitute for the source articles? Does the event tracking, is it useful? And the question which everyone usually asks when I give a talk like this, and there are more and more competitors every day, is what's the difference between Newsblaster and Google News? And of course, the first difference is that Google News does not have summaries. Google News selects one arbitrary sentence from that input set of clusters. So if you're given a system that has summaries versus one that has just this arbitrary single sentence, can you do better, is the question that we wanted to ask. So we ran a study where we had 2 user groups, 2 versions of Newsblaster, because we wanted to control for exactly the same set of events, same input articles. The control group used a modified version of Newsblaster, which did not have event tracking and had the Google News summaries, the one-sentence lines. The experimental group used the full version with event tracking and the full summary. And we did a task-based evaluation. The task was they were to write a report, and we modeled it after an ongoing evaluation that's part of the DARPA TIDES program. So they were given a topic to research and write a report on. They could only use Newsblaster for their research, and they were time restricted. And the question was, how well could they do in the amount of time that they had for these 2 different tasks? So we used 2 essay prompts on the different types of stories. One was a top story that everybody should be familiar with, and that was the bird flu, which was happening at that amount of time. And one was one that people probably didn't hear much about, and they would have had to have, done more reading at that point in time. So we had those 2 different things. We had 17 participants, and they were all students, but we looked at drawing them from very different backgrounds. We used an exit survey where we had both multiple choice questions and open-ended questions. We asked them to rate different features along a 5-point scale. And we also tracked their usage of the system, so what they looked at both on and off the Newsblaster site. And our results showed, well, both groups wrote reports of about the same length. The control group, though, had to look at twice as many source articles as the experimental group. The experimental group could often get the information that they needed from the summaries without having to go in and read the full-length source article. On the exit survey, we found, in the questions that we asked, we found that the experimental group stated that they found the summaries more useful. So 37.5% of the experimental group said they found the summaries the most helpful in doing the report, while 0 people in the control group stated that when given several choices. The experimental group spent more of its time within Newsblaster, that is on the Newsblaster features, as opposed to going to the source articles than the control group. So 62.5% for the experimental group versus 22.5% for the control group. The experimental group found what they needed with doing much less reading. So they needed to view fewer source articles in order to find what they wanted, and you can see the reported figures here. The experimental group felt less constrained by the time limit. They felt it was easier to do their task in the amount of time that they were given. These numbers on the last one are on the 5-point Likert scale. Okay, so we want to do more evaluation. There are some different kinds of things that we want to look at, but we think it does show that having the summaries does give you an improvement in doing one of these kind of tasks than not. That is what we're doing now. So in the initial one, we did not, and now that's what we're doing now. And a more
the comparison, maybe I missed this, but did you do a comparison of the Newsblaster generated summary to the full screen of Google snippets? You know, go down a level in Google News and just get the top 30 first lines from the article, where you can get a pretty quick holistic view of what's going on in the event. Where that might be an interesting thing to compare to a fully generated summary.
Yeah, we did. Well, I'm not sure I can answer that question well. I mean, it was within the Newsblaster interface, but it's very similar to the Google News one, where you have the cluster and then you can drill down into it. And so they could drill down. Now, in the Newsblaster one, you get the titles as opposed to the sentence when you drill down. And I actually would have to check what we did at that level. I know at the summary level, we put the one sentence.
If I am participating in this experiment, so when I was asked to write a report, I may just copy the summary.
Yes.
Any people done that? But in that case, I really don't need to look into a lot of articles.
Yes. Right. So the thing is that, yes, people often do use the summary to do the report. Now, the question is that good or is that bad? So, if you find what you're looking for, it's good. Then you don't have to, it limits, it's like a triage, you don't have to look further. The summaries, of course, can also help you determine when you have to look further and when you don't. We did do some other experiments with end users at one of the government agencies. And that was very interesting because this is their task. They do this, their task is, research this particular event and write a report on it. And time is critical. And they often did use the summaries. They would use pieces of it and then rewrite it. And when they could do that, they found it very helpful. And so that actually was very informative to us because they gave specific feedback on the forms of the summaries.
But it sounds like you're saying there's another side to this. I would imagine it would be that if the summary is somehow leaving out something important, they won't know what they didn't know.
Yes, so you do have, right, two sides to that. So the source articles are there. You can go further and look, and if they determine that they should, they can. It's going to be a trade-off because you have a certain amount of time to do it. It's very time constrained.
Which is whether the reports are good if you trust the machine. Or you could imagine they might be better because the person isn't as good as the machine.
Yeah, I mean, there are, you know, there are different sides to how you do that. I mean, I think if you did not, you know, without any kind of clue as to what's there, the task is much harder because you have far more information to go through. And at a certain point in time, you just can't go through all of that information. So, you know, although, I mean, you run the risk either way you do it, that you're gonna miss something.
I think it suggests at least the following experiment, that you give somebody a lot more time to then rate the quality of the summary without them knowing from what group it's coming from.
There are many experiments we can do. And we're doing a bunch more now. So, yeah, I mean, you know, for everyone in the room could say, you should do it this way or that way. So we've got a bunch of variants going on now, and yeah, that would be one.
Regarding the evaluation of the quality, have you considered the fact that, for example, two different news sources could talk about the same event with a contradictory point of view, using the same wording? So you could end up creating a summary that will have completely contradictory sentences. Did you look at this phenomenon?
Yeah, I mean, contradiction is definitely something that we've been interested in for quite a while. And we started off thinking that, you know, this is what we wanted to look at, was one of the things was contradiction. Well, contradiction is really hard. And actually, when you look at the source articles, it's very hard to find direct contradictions. We spent a lot of time like researching on events where we were sure there would be contradictions in there. And when it comes down to it, they often are not contradictions. They're just slightly different point of views. Or sometimes things have changed. And it's not a contradiction. It's just, it changed from the... We spent a lot of time looking at the Egyptian air crash, which happened, this tells you when we began looking at it, you know, around Boston, and where the U.S. was claiming that the pilot committed suicide. Well, very difficult to find direct contradictions in there. Still, you do get errors, and there are some very interesting errors that come out maybe at the end of the talk. If people want to know, I'll show a few of them, which I found when I was looking through today's demo. Yeah. We do a number of component evaluations, a lot, I shouldn't just say number, a lot of component evaluations where we look at the you know, when you're experimenting with different kinds of tools, we look at the quality of just one of those tools, and there it's a quantitative evaluation where we have a gold standard and we're going to assess precision and recall. We participate in the duck summarization and evaluation, although I think there are a number of issues with how that's run. But on the other hand, it creates huge amounts of data for experimenting with evaluation methodologies, and I think there's been a lot of progress in the field for how to do that kind of evaluation. Just there needs to be some more.
Most of the sites you crawl are advertising-based, and you say that if they use your crawler or summarizer, that they spend 60% of their time in your site. Have you gotten any pushback from any of the sites the news sites that you crawl? Because the Google format, where they just have the one-line summary, forces you to go look at the sites and see their advertising. Whereas your model, by being so useful, means they don't have to go there and then see the advertising and pay for the site that's providing the content for you.
Yeah, no.
Has anyone ever...
No. No, we haven't. And, you know, we went through various, like at one point, shortly after it came out, there was a fair amount of news. It was in the news, so it was in the New York Times, and then a number of other sites picked it up. And I worried a lot at that point in time about various things like copyright and, you had the nightmares overnight. Oh, my God, they're going to discover we're doing something illegal. But actually what happened was we had more news organizations then which contacted us and asked if they could be included So,
A lot of times on a hot story, the same sort of information, and one source will have some extra piece of information. Have you thought of trying to extract that and highlight that as an option after the main summary?
we haven't, but that would be something that we could look at doing with the update summaries to identify, sort of what's different and whether one of these things which is different is really important and should be included. So, yeah, that's...
Okay. And along the same lines, I was wondering if you looked at all or thought at all about sort of giving so for a user who's been reading stories on a 5-day basis, he goes on vacation for a week and he comes back, kind of wants to know what he's missed.
Yes.
You thought about modeling what he's read and then giving him like a delta. Like, okay, you'll remember that this was happening. Here's the 5 days you've been gone. Using that.
Well, again, it would be with the updates. The update summaries, the way they work is you have a background set of news, set of articles, and the new set of news. So it's just 2 sets, and you're doing the comparison between them. So you could vary, what those sets would be. And we did think about, initially when we were displaying, we don't really have an answer yet, but the update summaries, how do you do it? So we have the News Blaster summary and we have the update summary. Well, the News Blaster summary, since it looks at similarities, some of it will be background. So you probably could do it with some combination, but I don't know what the right combination is. Okay, so in the last part of the talk, I'm going to move into other media that we're looking at, and this will be much quicker than the News Blaster, but I'll try to give you a flavor of where we are. Well, people have been looking at news for quite some time. There is some discussion sometimes that maybe news is easier because it's written in certain ways that allows you to easily find the leads at the beginning. What if we move to other types of media which are less well structured? And so we've been doing that over the last 2 years with work on email summarization. This is joint work between myself, Owen Rambeau, and Julia Hirschberg, and there are a number of students who are working on it. Some of the issues, email is really somewhere between speech and written text. It has features of speech in that there's elements of dialogue. People are talking to each other and there's more context. You may be replying back to somebody else. There's elements of speech in that the language is much more informal than what you find in news. We don't have well-documented, well-edited, very grammatical sentences. There's a lot more informal language, elliptical references, and so forth, errors. On the other hand, there are less errors than you have in speech. You don't have the speech recognition errors. You don't have false starts. People do edit their email often before they send it. So you're somewhat in between. You also have more context that's explicitly repeated than you do in speech. So in email, people often use quotes, and in their reply message, they specifically quote the piece of email that they're replying to. And surely if they do that, we ought to be able to make use of it to help us in doing the summary. There are a wide variety of different types of emails, and we thought, well, we really ought to, summarization, when you look at written text, it varies depending on the genre, whether it's news or journal articles, it can be quite different. We certainly should look at the different types of emails and whether we use different strategies. And so it can be conversational, it can be decision-making, scheduling, event planning, etc. And then there are different reasons for doing summarization. So we may have huge quantities of email, a large mailbox, and want to summarize that for browsing. So we might have a News Blaster page for browsing a mailbox of email. Or we could use it for catch-up. So this is, your discussion. So this is, what we had where you join the discussion late, you've missed your email for a period of time, and you want to know what happened in this discussion while you were gone. So here you would summarize a thread. And in our work, we're focusing on this, the catch-up summarization. You're summarizing a thread. Since it's very new, the first part of our work involved study. And even collecting and annotating these different corpora took time. There are a lot of issues in getting an email corpora. We now have two. One is an internal one, which was used by the ACM for their event planning, the student chapter. And the other, we now have the Enron corpus, which was made public. And we've downloaded it and processed it in different ways. We've done some annotation of these, so we've asked people to do some handwritten summaries. There are, if you look in the literature, there generally are not summaries available of email and what would make a good summary. We've categorized the threads according to the different type and the messages according to what type of email it is. And we identified 3 different categories of email that we wanted to address. Email that works on planning events. This happened a lot in our ACM student corpus. They were planning lectures, invited lectures, various dinners, various kinds of things. Scheduling, of course, is one where it would be nice to have some summarization. And then information gathering, which we actually thought would be great for email, like news boards for classes.
Just clarification, are you talking about summarizing individual messages or summarizing threads?
Summarizing a thread.
Okay, all right.
Okay, and we've developed several summarizers that we're experimenting with. We started doing statistical extraction, but using features that are specific to email, and we're moving to some more category-specific summarization. So what do you need to do when you have an information gathering thread of email? Or what do you need to do when you have a thread which is planning an event? How does the summary change? Okay, and on our sentence extraction, we use features to identify what the key sentences are, and we looked at 2 types of features. Features that are used in many summarizers, non-email specific. So, for example, similarity of a given sentence to the centroid of a thread. And we also looked at email-specific features, so the fact that you have quoted material, how does the fact that you have a quote, and how do the words in the quote influence what you include? And we developed a rule-based supervised system making use of machine learning, where we trained on the human-generated summaries. In addition to the extraction, we generate wrappers around the sentences to show who said what. And I'll go through this fairly quickly. This is one of our set of data, the Columbia ACM board mailing list. So it gives you an idea of how much data we have, about 300 threads, and the different kinds of threads. So in our summarization by extraction, we start with the human-written summaries, but we want to determine which sentences from the email should we extract. So to create the training data, we first go through an automated step where we use SimFinder, the similarity tool, for each sentence in the human summary to identify the most similar sentence in the email, which we then assume as our gold standard. If we're doing extraction, that would be the sentence we want to extract. To learn the sentence extraction rules, we used Ripper, which is a rule learning algorithm, and we use both the basic and the email-specific features. And now to create new summaries, we run these learned rules on unseen data and add wrappers. This gives you an idea of where we are. So, if you're looking at F measure, you can see we do get an improvement when you use the email-specific features. 61% precision, so we still have a ways to go in getting a good summarizer, but you have some idea. And here's what we get as output. So this is the kind of summary that we would get. A wrapper like regarding meeting tonight on October 30th, 2000, David Michael Callan wrote, "Can I reschedule my C session for Wednesday night, 11/8 at 8? Responding to this, James Peach wrote, "Are you sure you want to do it then?" And responding to this, Christy Lauridsen wrote, "David, a reminder that you're scheduled to do an MS Office session on November 14th. So, gives you an idea, but there are some problems, and one of them has to do with the fact that when you've got what's called information gathering email, that is, somebody poses a question and you're looking for answers from a group of people, when you generate the summary, if you've got a question in the summary, you'd sure like to have the answer there also. So our next strategy is looking at how can we identify those questions and how can we identify the answers to pull them in. And so you've got some examples here in the statistical one where we've got 2 questions that are included and no answers to them. And so we developed a second version which does detection of questions. And here again we used a machine learning based approach. We trained on switchboard data because we have a set that's already annotated with what are the questions, and then we tested on the email, so we didn't have to do annotation. One problem here is that in email, many of the questions often start without question words. They start as declarative sentences. So, if you're available, do you want to come? Or, if you don't mind, could you post this to the class B board? So our initial results were good on precision, but low on recall. And when we went to handle these kinds of sentences, we got some improvement here on recall. I'm going to skip over the answers, which is another approach, which just gives you results again, and go to another kind of thread that we looked at, which was issue-oriented email. So again, a problem if you use sentence extraction. Here's a case where often you have an issue that's presented and people are going to argue before or against it in their email. And so again, you want to present the email and give the different points of view. A summary using extraction won't do it. So we get some idea that it's about a plaque. Somebody liked it, but we don't really know what's going on. If instead we could identify the issue, let me know if you agree or disagree with choice of plaque and especially wording, and could see the responses. I like the plaque, or I prefer Christie's wording to the plaque original. Again, we could get some idea of what the email thread is about. And so this is one that we're also working on. We have done some work where we work to isolate what the issue is, to detect the responses. Our work on classifying whether it agrees with the issue or disagrees is not done, and then we would want to extract the sentences. Our work so far has just been on isolating the issue. To do this, we developed an approach where we select the issue sentence based on the replies. So find the sentence in the first email of the thread based on how it relates to the different replies to that email. And we experimented with a variety of different approaches, all statistical, using a centroid-based approach and as well latent semantic indexing. If we combine all of the approaches to choose, they seem to be complementary, we can get a relatively good identification. Okay, and just to give you a flavor of the meeting summarization before closing, here, this is joint work with Berkeley, SRI, and University of Washington, where our goal is to be able to automatically summarize meetings and we'd like to do it by generating something that looks like minutes, where we highlight what were the decisions made in the minutes, in the meeting, and who agreed and who disagreed with the decisions. And our work to date, which was published this summer in ACL, Michelle Galley is the student doing this work. We've looked at being able to identify when somebody agrees or disagrees with a point in the meeting. Again, we use a machine learning approach with a variety of different kinds of features, but critically, we've looked at making use of context. So if we know that person X always disagrees with person Y, or has repeatedly disagreed with person Y, when we hear person Y responding to person X anew, are we more likely to have disagreement or agreement? And in fact, so we identified different ways that this kind of influence could go. And in fact, yes, there is a strong influenced by that, we do get an improvement in whether somebody is agreeing or disagreeing. To do it, we have to do two tasks, classifying a sentence as agreement or disagreement and determining who they're talking to, this addressee identification. And that's sort of where we are. So very beginning on meeting summarization, building some of these components on things which will make a different kind of summary there. So just to conclude, I hope to have shown you today that non-extractive summarization is possible today. That our studies show that having a good summary or a meaty summary, I guess I should say, improves access to needed information. That we have advances but still ongoing work on issues like tracking events, multilingual summarization, or perspectives. And that in our moves to new media, we get new challenges given the entrance of characteristics of dialogue and informal language. So, thank you.
In the meeting summarization, you're doing this on ASR transcripts of meetings, or?
We have, that would be ultimately the goal. It would be the ASR transcripts. It's joint, so people at some of the other sites are working on the speech recognition problems. For our experiments, we do them with the perfect transcripts, the human transcripts.
But you have some source transcripts of some sample meetings?
Yes, we have a collection of transcripts of sample meetings.
Going back to the news cluster, I can see the point of presenting, like a different perspective based on different countries, articles. Now, using the translation, it seems like I really want to see the motivation behind it. That is, by using the translation sentences or articles, you're going to introduce noises. And at the same time, you are trying to kind of choose the perspectives, different perspectives. In a sense, using, the articles published in different countries, right? So, so conceptually, I kind of really want to see the motivation behind that.
Okay, so, well, ideally, you'd like to do both on that. So you'd like to be able to fuse by have a summary from multiple countries and multiple languages, but then you want to be able to display the different perspectives by looking at one language separately from another language. So you'd like to be able to do both at this point in time. And when you do the fusion from different languages, while you lose some of the specificity of what's coming out of a particular country, you still gain the ability to browse in English over everything that's there within the decision to look in more detail if you find, so it's like a triage kind of thing where you immediately can use that to filter out what you're not interested in, what you don't want to spend time, looking at the translation or improving the translation or whatever.
So another question was kind of related to the contradiction issue. Some code was made by John Kerry, and then some code was made by, say, Dan Quayle or something. And then I heard that the same code, the different websites are saying two different things. So how are you dealing with this trustedness?
Okay, so that's another issue. So. Different people have their trusted sources and their untrusted sources. And, some people have said to us, again, we want to move to, and the work by Luis Scrivano is pushing us in this direction of moving to personalized versions of News Blaster. So certainly you can personalize by, these are the sources you want included and these ones you don't. There are other ways. The work that Luis Scrivano is doing is looking at being able to personalize by, having filters and still having your browsing ability, but only on those topics that you're interested in browsing. I think in the back.
Well, the question was actually related to personalization. So I was thinking right now it's important to have that many sources of news because we want to have different opinions. And if you don't have a balance, I don't know, if you don't have a balance across your sources, you might get, especially for this campaign, only the Republican or, I don't know, the Democrat point. So it would be really useful, but the answer is that I can specify the sources that I want, and then basically we still have this division of opinions, because, I don't know, from a social point of view, they are really good, right? And with this fusion, we lose that kind of thing in society. So.
Yeah, I mean, actually, like the point you're making now, that's a good idea, because we're interested, one of the things we're interested in different perspectives. You know, content is one thing, and we can apply the update summarizer to look at differences in content from different sources. But one of the other things that's interesting is difference in attitude, which is often reflected in the language that's used. And when you look at different countries, you know, now it complicates things because you have to look at not only, you know, different wording that's used, but from different languages. But that actually is a very good suggestion of a test bed to start looking at it, you know, in Republicans versus Democrats, where you've got the same language but very different perspectives, and the attitude should be different. So.
From that perspective, as far as impacting society, it would be interesting. You could personalize saying, you know, these are my trusted sources and get a summary, but then have a pop-up that says, do you realize that there are other points of view?
Yes,
that'd be of interest.
So to me, you know, I don't really, I am not really trust with summarization. It's not because of the source of information. It's because of the, you know, as Ken said, we may miss very important context information. So if you take things out of context, then you will get, you know, totally different opinion from that. I remember when I watched Fahrenheit 9/11. At the very beginning, it said, you know, after the first plane struck the World Trade Center, Bush decided to stay for picture taking opportunity. So I'm not a Bush fan, but I don't think this is fair to Bush, because, you know, it didn't tell the moviegoer that Bush was informed that it was an accident at the very beginning. So if your summarization does not provide this information, then how can I trust that?
Yeah, this is, I mean, I think it comes back to the same question that was asked earlier, and we have had quite a bit of discussion with people who do this for a living. These are our funders, you know, so we get quite a bit of these people who will come in as potential end users and look at what we have, and you know, one of the requests was that, given a summary, that you must be able to go back to the source and see where that statement came from. So, you know, that's both for issues of trust and issues of context. Now, that means, you know, someone needs to decide when they're going to go back to the source and when not. But that was key in, you know, sort of doing the development, that you need to be able to have links from the summaries back into the source material where it came from. You know, it's a trade-off, and I think the fact is that there's so much information out there today that, you know, you could say, well, we don't want summaries at all because of the potential of misleading, but it's just simply not possible in today's, you know, with the amount of information that's out there, to be able to do a browsing and see everything, to make sure that you've gotten everything, and this is a way to help you get some control over that.
Do you have enough information to give like a little icon kind of indication of there's various opinions on this, you want to go check the sources, or this is all, everyone's saying exactly the same thing, the summary is pretty close here. Maybe a rating of the summary as to how similar or how complete it is?
Well, we do have work going on at Columbia on identifying opinionated text and being able to determine whether an opinion is positive or negative. So, you know, you could, I mean, I know there are different ways to do what you're talking about, but you could, for example, determine whether, you know, you've got your source articles are sharply divided on a particular issue, and so your summary may not represent that, you know, how sharply divided they are. These are all possibilities. Actually, you know, it's nice to give a talk and get some input about what people think would be interesting, because It's a test bed. It's nice and it's running and it shows that things can work, but it's one that, the problems are hard and there are many, many different directions you could go in. Yeah.
This is sort of, just a quick remark, but to me it seems that, one thing that I would be interested in looking at news is actually identifying the outliers, because, in the manufacturing of consent that you actually see, it's pretty much a mass of, moderate disinformation, but then there's a few sources that don't quite align with the other ones, and that's very often where you find the additional information that is actually relevant. So it would also be interesting to sort of, not only have a summary, but maybe a little pointed to, here are some outliers that don't quite fit in, that don't quite agree.
Yep, lots of ideas for direction. So.
I think we'd like to thank Kathy for doing a wonderful job.